Hello and welcome to The Explainer. What if I told you that a brand new technology could be about to turn the entire world of computing completely on its head? Well, get ready, because today we are diving deep into prompt-oriented programming. Just think about that for a second. Is it actually possible to give a computer complex commands, define logic, and get precise results without ever typing if, else, for, or while? The answer might just surprise you, and it's at the heart of a truly revolutionary innovation. Yep, we are talking about a totally new way to program. And this innovation, called prompt-oriented programming, or POP for short, isn't coming out of Silicon Valley. It was actually developed right here in Brazil by Elias Andrade of Replica AI Solutions, and it promises to redefine the very essence of computation. Okay, so let's get into it. What exactly is prompt-oriented programming? Well, it's a method where instead of writing code, you write instructions in plain natural language. These instructions are structured, maybe in a YAML file, which acts like a kind of manifesto. With this, you define the behavior and the logic that a large language model, an LLM, is supposed to follow. And here's the kicker. It all happens in real time, without ever touching a single line of the original source code. So the POP architecture is built on 4 key blocks. First, you have the LLM agent, which is basically the brains of the whole operation. Second, the behavior YAML. That's the manifesto that tells the agent who it is and what its job is. The third block is the modular RAG, which stands for a Retrieval Augmented Generation, a system that fetches outside information to give the agent context. And finally, you have the audit YAML, which is a log that the agent itself generates to record its actions, giving you total transparency and control. And right here, you can see just how simple and elegant this process is. On the input side, we have the comportamento.wml file. This acts as the rulebook, defining the agent, its goal, and the expected format for the response. Then, on the output side, the agent itself generates the output.wml, a precise and totally auditable record of what was requested. The instruction was given in structured natural language, and the result was real computation, programming with no code. So why is this so revolutionary? Because we're not just talking about a new technique here. We're talking about a fundamental shift in how we interact with and control machines. A whole new computational paradigm. This quote just nails the essence of this change. Before, we used to program AI as a tool. But now, with POP, we are programming through the AI. The LLM isn't the object anymore. It's become the development environment, the runtime, the compiler, and the executor, all rolled into one. And this brilliantly illustrates just how fundamental this shift is. When you compare the PLP architecture to a Turing machine, the theoretical basis for all of modern computing, you see a perfect one-to-one fit. The prompt in the YAML file, that's the input tape. The LLM, it's the read/write head. The natural language instructions, those are the transition rules. And the structured output is the output tape. This isn't just a clever metaphor. This is real, bona fide computation. So how does this stack up against the paradigms we already know? Well, imperative programming tells the computer how to do something. Declarative programming tells it what to do. And object-oriented programming wraps everything up in neat little objects. POP is different. It's emergent, it's dynamic, and it's controlled by intent, by semantics. It doesn't really replace the others. It carves out its own category. It's a completely new way of thinking about computational logic. But you know, theory only gets you so far. The real magic happens when this virtual computation breaks out of the screen and starts interacting with the real world, and that's where the impact of POP becomes massive. Just look at this execution chain. It all starts with a simple prompt in natural language. The LLM then generates not just text, but an executable YAML file that contains, say, a database query. An external parser then reads that YAML and executes the command. All of a sudden, a simple request in plain English can trigger a complex database query, interact with an API, or even control an IoT device. So the crucial point is, where does this Brazilian innovation fit in on the global stage? Well, while a lot of theoretical research around the world is busy debating whether LLMs can be Turing machines, and while tools like LangChain are creating things like function calling, POP goes a step further. It proposes a complete pragmatic architecture for external execution, turning all that theory into a robust, auditable, and practical framework. It's a leap from research straight into production engineering. And the applications are absolutely mind-blowing. We're talking about controlling robots and Internet of Things devices with voice commands, DevOps automation that adapts on its own, auditing systems that self-document in real time. We can orchestrate multiple AI agents to collaborate with each other. POP is basically a bridge to a much more autonomous and intelligent future. And all of this leads us to a long-term vision where prompt-oriented programming might not just be an option, but the standard for building the complex systems of the future. And the vision behind POP is incredibly scalable. The architecture was designed with 7 levels of complexity, which you see here. It starts at level 1 with a simple prompt, but the ambition goes so much further, evolving up to level 4, where one agent can program another agent, level 6, an entire ecosystem of AIs configuring each other, and finally, level 7, a self-evolving AI superstructure capable of reconfiguring its own architecture. Which leaves us with one last question. If the language we use to communicate every day, with all of its nuance and its semantic power, becomes the new source code, if our intent becomes the instruction, then what really is the limit for what we can create and compute? Thanks for watching The Explainer.